Hi, welcome to another science tutor lesson. I'm your tutor Nathan, and today we're going to be covering the topic motion in a straight line. Alright, so the first thing we want to discuss is the difference between scalar and vector quantities. Now, a scalar quantity is a physical quantity that has only magnitude. Alright, only magnitude or size. And examples of scalar quantities are things like mass, the mass of an object, which only has a size, temperature, right, which only tells you how hot or how cold the object is, and time. All of these physical quantities only have a magnitude or a size, whereas you have other physical quantities that not only have a size, they also have direction. Right? So they have a size, and that size is specified in a particular direction. Right? So examples of these vectors, which have both size and direction, are physical quantities like force, pressure, and velocity. So you need to know that scalars only have magnitude or size, while vectors have both size and direction. Alright? So now that we've covered the difference between scalar and vector quantities, we can really move on to the topics that we're going to focus on today for motion in a straight line. And the two topics that we want to start with are distance and displacement. Now, distance is simply the linear separation between 2 points. Right? So basically, if you start at one point, A, and you move a certain distance to another point, B, and you measure that distance, and say you find it to be 2 meters, that is the distance, the linear separation between 2 points. Distance is a scalar quantity, which means that when you speak of just a distance, you're only concerned with the separation between the 2 points and how big that separation is. So, when you speak of a distance, you're talking about the separation between 2 points. For example, if Bob, this stick figure, starts off at location A and walks 2 meters over to the right, or in any particular direction, because like I said, this is a scalar quantity, and we're not really interested in the direction per se. And he walks that 2 meters. So the distance that is covered is 2 meters. If he was now to walk back 1.5 meters, then the new distance in this case would be equal, the new distance would be equal to 2.5 meters. Sorry, the new distance in this case would be equal to 2 meters plus 1.5 meters, which is equal to 3.5 meters. And if instead of walking 1.5 meters, he walked the 2 meters back to his original starting location, then the new distance in that case would be equal to 2 meters plus 2 meters. which is equal to 4 meters. Right? So again, distance is just the net separation between 2 points, or how much ground you cover, if you want to put it in very, very simplified forms. Right? And this is a scalar quantity, so it only has a size. So we would say that the distance Bob covered is equal to 4 meters. Alright? So that's distance. Now, the next topic that we're going to cover is very similar, and it's called displacement. Now, what displacement is a distance that is moved in a particular direction. Alright? So displacement is a distance moved in a particular direction. And because you have the direction component, then that means that displacement is a vector. Right? Remember, vector quantities have both size or magnitude and direction. So let me give you another example. Alright? Suppose John, in this case, stickman John, starts out at location A and walks 2 meters to location B. We'd say that his displacement, which has the symbol S or X, is equal to 2 meters, which is the magnitude of the distance moved, but it's 2 meters to the right, because the direction he moved from A to B was from left to right. So John moved 2 meters to the right. Alright? Now, just like with the earlier case, suppose he's reached B. Alright? So let me erase him, because we need to make this very clear. And he decides to walk back 1.5 meters back in the direction that he came from. Right? Now his displacement S is equal to 2 meters minus 1.5 meters, still to the right. Right? The reason for this is, remember that a displacement is the distance moved in a particular direction. Right? And if you want to be technically correct, displacement is the net distance moved in a particular direction. He's moved 2 meters to the right, but come back 1.5 meters to the left. So the net distance he's moved to the right is 0.5 meters. Alright? So his displacement is now 0.5 meters to the right. So imagine what would happen now if, instead of moving 1.5 meters back in this back from B to A, he moved 2 meters from B to A. In other words, he came back to his original starting point. So John is back right here. What would his displacement be? And the answer is the same. The displacement is always the net distance moved in a particular direction. And in this case, the net distance he's moved is 2 meters to the right minus 2 meters to the left, which is equal to 0 meters. Alright? So his net displacement is 0. He has not gone anywhere. Alright? So the difference between displacement and distance that we want you to remember is that displacement is a vector. It's specified in terms of not just the size, which would be the 2 meters, but also the direction in which that 2 meters was moved. Right? So displacement is a vector. Distance, which is the simpler form, is just a scalar and only has size or magnitude. Alright? So we've covered distance, we've covered displacement. Alright? So in the next video, we're going to cover speed and velocity, which are derived from distance and displacement. So till then, feel free to like and share the video, right? Put it on Facebook and Twitter, and make sure to come back for the next video.